Okay, good evening, everyone. So we are on day two of the AI practitioner exam prep week. Yesterday, you guys learned about AI fundamentals and AWS services. Today, we will be learning about machine learning. So let's go ahead and get started. Machine learning can feel like a black box at first, but don't let that throw you off. The goal is to understand the key ideas behind how machines learn from data and how you can use that power to build smarter tools. One step at a time, and it'll start to click. Let's get into it. And as we're going through the lessons as well, at the end, I'm just gonna recap everything, really show you guys what you need to know for the exam, because there is a lot of information. There's a lot to learn in AI, so I'll just recap everything. Remember, you don't need to dive into the math or build full machine learning models right now. Focus on grasping the core principles, how data is used, what learning really means, and when different machine learning approaches make sense. If you can explain the idea behind a model and recognize the right tool for a situation, you're exactly where you need to be at this stage. So one thing about the AI practitioner exam, there's a lot of questions that are scenario based. So it'll give you a certain scenario regarding a fake company, and then they'll say what AWS service would be best utilized for this, or it'll it'll say something like this is having a problem with overgeneralized uh, or it's having problems with outputs. What is the reasoning behind it? Things like that, and you'll just have to give a term or select from the answers and give a term on what you think is correct. So learning objectives today, we are going to learn how to prepare data for model building. We're going to learn types of data and types of learning, and then we're going to understand the difference between bias and variance. We have three lessons today. First one will be on preparing data and model building. Second, data types and learning types. And then third one will be bias and variance. We also have some additional resources and the practice exam for today, which is mainly contains everything on machine learning fundamentals. So different questions on that. It's not the full scope. It's just specifically for that domain. Are there any questions? There's no questions. Let's go ahead and get started with the first lesson. So intro to machine learning, lesson one, preparation and model building. This lesson covers the foundational steps of any machine learning project, data preparation and model building. Understanding how to clean and structure data along with the model training process is essential for the exam. So why is data preparation important when working with artificial intelligence or machine learning? One of the most important and often most time-consuming steps is preparing the data. Think of it like cooking. Before you can make a great meal, you need to wash, chop, and measure your ingredients. Similarly, before an AI model can learn, it needs clean, structured, and meaningful data to learn from. Raw data from the real world is usually messy and unorganized. It may include missing values, errors, duplicates, or irrelevant information. If this data is fed directly into a machine learning algorithm, the model's performance can suffer, sometimes drastically. That's why data preparation is critical to building an effective AI system. So the steps in data preparation are data collection, data cleaning, data transformation, engineering, and data splitting. These are key terms to know. So data collection involves gathering raw data from sources like files, databases, websites, APIs, sensors, etc. So it's just pretty much getting all the ingredients that you need. Data cleaning is removing errors, duplicates, or incomplete records. Think of it maybe like getting rid of fruits that are bruised or uh, ingredients that are not up to par. Data transformation, converting data into a consistent format, such as changing text to lowercase or converting dates into standard formats. That could be like maybe chopping up the ingredients that you have, preparing them so that you can actually throw them into the pot. Feature engineering, selecting and creating the right input variables, uh, which are features that will help the model learn effectively. Maybe for this example, maybe after you're done cutting all the different ingredients, maybe one of the chunks is too big or something, so you throw that out because you don't need it, and you want your meal to be presentable, not have that odd uh piece. And then data splitting, dividing the data set into training, validation, and test sets to properly evaluate the model's performance. Let me try to think of an example for that. Maybe creating different plates. Uh, uh, that's the only example I can think of right now. All right, so what is model building? Once your data is prepared, the next step is model building, the process of training an algorithm to learn patterns from the data. In other words, you're teaching the computer how to make predictions or decisions based on examples. During model training, the algorithm looks at the features in your data, learns which features are most important for making predictions, and adjusts itself to reduce errors. This process is called optimization. The result of this is a machine learning model, and a definition of it, you'll probably see this on the exam as well, is a mathematical representation of what the system has learned from the data. Training, validation, and testing. So these are the different sets that we were talking about. Training set is the data used to actually teach the model. Validation set is used to tune and improve the model's performance during training. So there's the initial data, and then while you're still training it, you're going to use the validation set just to improve on it. And after everything has been set in place, you use that the test set. So used after training to evaluate how well the model performs on unseen data. This helps prevent the model from simply memorizing the training data, which is called overfitting. And we'll get into this term more later on when we get to bias versus variance. So this is a key term as well to keep in mind. AWS tools to help. AWS service Amazon SageMaker offers integrated environments to handle data preparation, model training, and deployment. These tools often automate many of the steps while giving you flexibility and control. Data preparation and model building are the foundation of any successful AI project. Clean, well-structured data helps the model learn accurately, while thoughtful model building ensures that the system learns what the system learns is actually useful. Just like a well-prepped kitchen leads to better meals, well-prepared data leads to better AI. So let's get into the practice questions. Uh, what is the process of selecting and creating the right input variables to help a model learn effectively called?
Feature engineering.
Let's see. Yep, it is feature engineering. Question 2. What are the three parts a data set? What are the three parts a data set is usually divided into for model training?
Testing, validation, and training.
Yep. So from the beginning in order, it's training, then validating, then testing it. Question 3, what is it called when a model simply memorizes training data instead of generalizing to new data? Someone else besides Nick?
Overfitting.
What'd you guys say?
Overfitting.
Yep.
Overfitting? Let's see. Yep. Nice work. Question 4, which AWS service offers integrated environments for data preparation, model training, and deployment? Someone besides Nick, Cam, and Monica? No.
SageMaker.
What was it, Edison?
SageMaker.
SageMaker, let's see. Yep, yes it is. Question 5, what is the result after an algorithm learns patterns from data during model training?
Machine model. Machine learning model. A model.
Yep, let's see. Yep, a machine learning model. Great work. Summary, you now understand the critical importance of data preparation and the key steps involved: collection, cleaning, transformation, feature engineering, and splitting. How model building trains algorithms to learn patterns from data through optimization, why data sets are divided into training, validation, and test sets to prevent overfitting, and that Amazon SageMaker is the AWS service for handling data preparation, model training, and deployment. Are there any questions before we move on to the next lesson? Okay, let's go ahead and move to lesson 2. So lesson 2 is about data types and learning types. This lesson will cover the foundational concepts of data types and learning types in machine learning, understanding the differences between structured, unstructured, and semi-structured data, and knowing when to use supervised, unsupervised, or reinforcement learning. And this is this all these terms that I just highlighted are going to be on the exam. Understanding the data behind AI. So AI and machine learning systems depend heavily on data, but not all data is the same. Different types of data lead to different types of learning outcomes. To build an effective AI system, it's important to understand both what kind of data you're working with and how the data is used for learning. Just like a student needs the right study material to prepare for a test, a machine learning model needs the right type of data to learn the task at hand. Some data is labeled, some is structured, and some is messy and unorganized. Each kind plays a role in how an AI system is trained and what it can do. So the types of data in AI, the three most common ones are structured data, unstructured data, and semi-structured data. You guys really need to know these terms for these types of data for the exam, as they'll be heavily be on there. So for structured data, it's organized into rows and columns like a spreadsheet or database. Examples would be sales records, customer information, and sensor data. It is easy to process using traditional machine learning algorithms. For unstructured data, it doesn't follow a clear format or structure, and examples of that would be text documents, because think about how the text within that document is just it's just in there. It's not, you just got to parse through it pretty much. Images, audio files, video recordings. This requires more complex models like deep learning to interpret. Semi-structured data is a mix between structured and unstructured data. Examples of that would be JSON or XML files, which have some organization, but not as rigid as a table that has things like keys and values. This table kind of just goes over what we just went over. So it gives you the three different types of data: structured, unstructured, and semi-structured. Talks about the formatting. So structured data usually has rows and columns. There's no predefined format for unstructured. And semi-structured data is hierarchical. So it has things like tags or keys. Goes over the same examples that we just listed off. And then it talks about the processing. So structured data is pretty easy to process, sort, and query. Unstructured data is complex to process, often needs deep learning. And then semi-structured data, it's easier than unstructured, but it does require parsing. Best models to use for each type of data is, so for structured data, you would mainly use a traditional machine learning. Unstructured would be deep learning, and then semi-structured would be varies. So let's go over quickly what the difference is between traditional machine learning and deep learning. So traditional machine learning learns from features that humans create. So you decide what information the model should look at. An example would be if you're trying to predict house prices. You give the model features like square footage, number of bedrooms, zip code, year built, in order for the model to make a decision. The model is usually simpler and needs less data. This is like giving someone a checklist of important clues also. And you decide what matters, and they learn from that, what you just told them. Deep learning, on the other side, learns features automatically from raw data. You don't have to give it anything. It can learn on its own. So you give it that raw input. So it can be images or a text document, audio, and it figures out the important patterns on its own. This needs a lot more data and more computing power, but can learn very complex patterns. An example for this would be uh, uh, this would be like someone who can examine a picture and figure out what's important without you telling them. So you don't need to like intervene on their decision. Whereas traditional machine learning, you're giving them everything they need to make their decision. Uh, any questions on that? Okay, types of learning in AI. Once we know what kind of data we have, the next step is to understand how that data is used to train the model. This is where learning types come in. These are the different ways machines learn from data depending on how much guidance they are given. So the types of learning in AI that will be on exam are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So there's about four. Supervised learning, the data is labeled and it's labeled with the correct answers. The model learns by comparing its predictions to the correct ones. Example, a data set of images labeled cat or dog used to teach a model to recognize animals. It's used for classification or regression. Unsupervised learning, data is not labeled. The model looks for patterns or groups in the data on its own. And then an example would be customer data used to group shoppers into different segments without knowing their buying habits in advance. It's used for clustering, dimensionality reduction, and anomaly detection. So clustering, in quick terms, I don't think it's going to be an exam, but it's an AI technique for grouping similar items together without being told what the group should be. Dimensional reduction is the process of simplifying data by reducing the number of input variables, so the features, while keeping the important information. And just to go over what feature engineering is again, it's the process of choosing, improving, or creating the input variables that help a model learn better. So an example, imagine you have a spreadsheet with 100 columns of data. Many of those columns may be redundant, noisy, highly correlated, or not very helpful for learning. So dimensionality reduction creates a smaller, simpler version, maybe only 2 to 10 important features so that the model can learn more effectively instead of having those 100 columns. Another example would be maybe you have measurements of a person. So you have heights in inches, heights in centimeters, heights in meters, weights in pounds, weights in kilograms. Those are basically just two real pieces of information, height and weight, repeated in different units. So dimensionality reduction would shrink this from five features down to two, without losing meaning. And anomaly detection is exactly how it sounds. It's the process of finding data points that are unusual or don't fit the normal pattern. It's like spotting the odd one out of the group. So an example for that would be bank monitors credit card transactions. And most purchases are small and local, but suddenly there's a $5,000 purchase in another country. The model will flag it as an anomaly and possible fraud. So let's continue on uh, through to the other two different types of learning. So far we went over supervised learning and unsupervised learning. Semi-supervised learning is a mix of labeled and unlabeled data, useful when labeling is expensive because it is, or time consuming. Example, a small set of medical scans labeled by doctors with a larger set of unlabeled scans. Reinforcement learning. The model learns through trial and error. It takes actions in an environment and gets rewards or penalties. An example would be teaching an AI to play chess or control a robot. I also did post a link on the classroom channel. I think it was like 2 weeks ago. It was AI learning how to play, I think, soccer. The YouTube channel is called AI Warehouse. That's a pretty cool channel to check out. Just take a look at a few of their videos. It's pretty interesting and it's just fun to watch. Um, Next, we have a diagram of machine learning with three different types of the learning, and then within those, it just has use cases and examples. Understanding data types help you decide how to organize and prepare information for AI models. Understanding learning types help you choose the right training approach. Whether you're working with structured data in a table or raw images from a camera, there's a learning method that fits, and knowing which one to use is key to building successful AI systems. So let's get into the practice questions. Question one, what type of data is organized into rows and columns like a spreadsheet?
Structured data.
Let's go ahead and see. Yep, structured data. Question two, which learning type uses labeled data with correct answers to train a model?
Supervised learning.
Yep, let's see. Supervised learning, yep. Question three, what type of learning finds patterns or groups in data without labels?
Unsupervised learning.
Let's go ahead and see. Yep, unsupervised learning. Question four, which learning type teaches a model through trial and error using rewards or penalties?
Reinforcement learning.
Let's go ahead and see. Yep, reinforcement learning. And then question five, what type of data includes images, audio files, and video recordings?
Unstructured data.
Let's go ahead and see. Yep, unstructured data. So summary, you now understand the three types of data in AI: structured, unstructured, and semi-structured. The four types of learning: supervised, which uses labeled data; unsupervised, which just finds patterns within the data; semi-supervised, which is a mixture between labeled and unlabeled; and then reinforcement learning, which is pretty much trial and error. You also understand how to match data types to appropriate models. Structured data uses traditional machine learning. Unstructured data needs deep learning. And why choosing the right learning approach is essential for solving specific AI problems effectively. So let's go back up here. Over here it says whether you're working with structured data in a table. So what kind of learning would you use with structured data?
Supervised. What's the question? Sorry.
Yeah, what kind of learning would be used when you're working with structured data?
Supervised learning.
Yep, yep. And then how about if you're working with raw images?
Unsupervised.
Yep, because it is not labeled. Let's quickly go through it again, see key terms. So yeah, my recommendation is to just study up on structured data, unstructured data, semi-structured data, and learning the difference between them and when you would use them, or what the difference is between them. And then also which models you would be preferred to use for each type of structure, each type of data. And then also learn uh, the different types of learning. Next, any questions on lesson 2? Okay, let's go to lesson 3. Lesson 3 is about bias and variance. This lesson explores one of the most fundamental concepts in machine learning, the bias versus variance trade-off. Understanding how to balance model complexity is essential for the exam. Why models make mistakes. When training a machine learning model, the goal is to find a sweet spot. The model needs to learn the true underlying patterns in the data, which means it's a good fit, without also learning the noise and random junk, which means it's a bad fit. This challenge is the core of model building. We use two terms to describe the types of errors a model can make, and this is bias and variance. Think of it like an archer aiming at a target. Low bias, low variance equals good. All arrows are in the bullseye, and then high bias, underfitting. Uh, all arrows miss the bullseye but are clustered together. The archer is consistently wrong. And then high variance, another word for overfitting. The arrows are scattered all over the target, and it's not clustered together. The archer is inconsistently right and wrong. So what is bias or underfitting? Bias is the error from a model being too simple. It makes strong, incorrect assumptions about the data and fails to capture its true complexity. This is also called underfitting. Symptoms, the model has high error on both the training data and test data, and it's just plain wrong. So this will be on the exam, and it'll ask something like, it'll just ask you the model, exactly what it says. The model has high error on both the training data and test data. What is the correct term for this? And then you just choose bias for that question. A high bias model, like a simpler linear regression, tries to fit a single straight line to the U-shaped data. It will be wrong everywhere because the line is too simple to capture the real pattern. The rest of the lesson talks about this U-shaped chart, so let's go ahead and look that up. I never saw this chart on the exam. I usually saw this one right here, but it's just nice to look at it, just to for familiarity. AI U-shape. So it'll kind of look something like this. Again, this is not going to be on the exam, but it would be good to know. What is variance? So another word for it is overfitting. Variance is the error from a model being too complex. It's too sensitive and learns everything from the training data, including the random noise and unimportant details, which is also known as overfitting. Symptoms, the model has perfect near zero error on the training data, but has terrible high error on unseen test data. So on the exam, you'll see exactly what this says. The model has no errors on the training data, but has errors on new unseen data. If it says something like that, you'll know it's variance. So uh, this line right here would be good to know, correlating to variance, as well as this one, which correlates to bias. An example of variance, you use an extremely complex model, like a very deep decision tree on that same U-shaped house price data. A high variance model will wiggle its prediction line to hit every single data point perfectly. It has memorized the training data. The moment you give it a new house price to predict, its memorized rules are useless, and its prediction will be wildly wrong. So another way to think about bias versus variance is that bias is how close you are to the correct answer overall each time you get an output. And variance is how close together the outputs are to one another, even if they're sometimes far from the correct answer, as shown below. I guess another example is think about how if your model is full or different, full of different kinds of oranges as the data, and then the expected output of the model is an apple based on what you give it. You're not going to hit the mark for every single time because the data was way too simple. It's just filled with oranges. It only knows about oranges. Um, and then for the variance, for a high variance, think about how if you have every single kind of fruit in the world as the data, so it's really complex. The model might pick up some unusual patterns from all that data that is not relevant, and you give all sorts of and it gives you all sorts of unrelated outputs, which can be seen over here. Um, so the bias variance trade-off, you can't get rid of both errors completely. This is the trade-off. As you make a model more complex, such as adding more features or layers, its bias decreases. The U shape, it fits the U shape better, but its variance increases, so it's getting more complex instead of being too simple. But then it starts memorizing noise. As you make a model simpler, its variance decreases. It stops memorizing all that noise and unrelated data, but its bias increases. The goal is to find a sweet spot. You don't want it too complex. You don't want it too simple. And the point of ideal complexity where the total error is at its lowest. So over here for the chart, you just so if you have a so high bias, like we were saying, underfitting is another word for bias, but really it's for high bias. And then overfitting would be for high variance. So if you have a low variance and high bias, you would have everything grouped to one another, but it's far off from the actual expected real output. If you have low bias, if you have a high variance, everything is just going to be spread out. So the model was too complex, so it picked up all sorts of different patterns and information from that data, and it's giving you answers from all over the place, answers slash outputs from all over the place. And these are just so if the best thing to have is a low bias and low variance, and then yeah. So any questions on that, on bias or variance? This might be a little bit complicated at first, but just keep on uh, researching and trying to dig into it and really solidify your knowledge on this because this will be for sure be on the exam.
It's like marksmanship. So variance is precision. So low variance is a high precision, and bias is accuracy.
Yeah, yeah. So yeah, pretty much. So bias is how close you are to the correct answer, and then variance
Variance is
is,
how like consistent you are, be it
mhm.
consistently wrong or consistently correct.
Yep, yep. Any other questions or insights? Okay. How to fix this? So this brings us to how do you find that sweet spot? You tune the model by changing its settings, which are called hyperparameters. Hyperparameters are the knobs on a model that control its complexity. For a simple model which has high bias, you can turn up the complexity knob. For a complex model, high variance, you can turn down the complexity knob, and this is called regularization. Finding the best combination of these knobs by hand is extremely difficult and slow. This is where AWS service for custom machine learning comes in. For the exam, you need to know that Amazon SageMaker has a feature specifically for solving the bias versus variance trade-off. This is called the automatic model tuning, also called hyperparameter tuning or HPO. And how it works is you define your model. You then tell SageMaker the range for the knobs you want to try. So something like try tree depths between 2 and 30. And then SageMaker automatically trains hundreds of different versions of your model, each with a different knob setting. It then uses the validation data, which we went over lesson 1, to see which version has the lowest error on unseen data. And it reports back to you with the winner, which is the best tuned model that has found the sweet spot between bias and variance. So whenever you think about machine learning, just think about SageMaker. It'll handle everything for you. Practice questions. Question 1, what is it called when a model is too simple and fails to capture the data's true complexity?
Underfitting?
Let's go ahead and see. Yep, underfitting or bias. Question 2, what is it called when a model memorizes training data and performs poorly on new data?
Overfitting.
Let's see. Yep, overfitting. Question 3, besides Nick, what are the knobs that control a model's complexity called?
Hyperparameters.
Let's go ahead and see. Yep, hyperparameters. Question 4, which Amazon SageMaker feature automatically finds the best model settings to balance bias and variance? Someone besides Nick and Cam?
Automatic model tuning?
Let's go ahead and see. Yep, automatic model tuning or hyperparameter tuning / HPO. Question 5, a model has near zero error on training data, but high error on test data. What problem does this indicate?
Overfitting.
Overfitting.
Let's go ahead and see. Yep, high variance, which is overfitting. So summary, you now understand what bias is when a model is too simple and consistently wrong. What variance is when a model is too complex and it memorizes training data, failing on new data. The bias versus variance trade-off, balancing model complexity to minimize total error. And that hyperparameters are the knobs that control a model's complexity, and how SageMaker automatic model tuning automatically finds the optimal hyperparameters to achieve the best balance, solving your bias versus variance problem. Are there any questions on lesson 3? So again, bias and variance, really key concept you have to know for the AI practitioner exam. Just study this chart right here. And also know how to fix it and be able to explain what it is. Learn this line over here because it will definitely be on the exam. So just match bias to this and then match variance to this line right here. If it does good on the training data, but bad on new unseen data, it's variance. Any questions overall? Okay, nope. So that is the end of our lecture for today. Let me go ahead and stop the recording real quick.